Hi, this is Ken. How's everything going? Today I want to have a little bit change because I manually pick up a question from the list of 4 queues. Today's kata is called a Simplistic TCP Finite state machine. In this kata, we are asked to write a simplified version of an FSM of a TCP session. In the explanation part, here are all the different events that can happen in this FSM, and this is a list of possible states within this FSM. So for each state, when there's an event like this one, app passive open, it will change its state to listen, right? If the event is app active open, then it will become sing sent. Sounds very simple. Actually it is. In this given example here, because the initial state is closed, so when the first event is app passive open, the state becomes listen after this event, and the second one app send. So we just need to search in this state when this event happens, then the state becomes sing sent, right? The third event is receive sync act, which is here. So the final state is established as the result should be returned. The second example is quite simple. In the state of closed, we received an event app active open, and the state will be sing sent. In the third example, which is a little bit different from the first two, in the initial closed state, we receive app active open, which is this one. So the state will become sing sent, and then we receive sync act, which is this one. So the state will become established, and then app closed. Then we'll have a state of sing wait 1. And it becomes time wait after we receive fin act. But in the last event, when we are in time wait, there isn't a possible state change of receive act, so we should return error, right? Let's head to the practice directly, since this is quite simple. Alright, the first thing we can do is to have a static map of this state event switching. So we can define this as a dict where this is a state. We can have another dictionary within each state to identify which final state should be after receiving an event. We can do it like this. FSM. So this is state. For the state closed, we can have this event. Then the return should be listen. All right, and for this event, we should have a state as sing sent. Cool. For the second state, when we receive synced, the state should become sing received. And when there's an event of absent, the state should become sing sent. And the third event, app close, should make the state become closed. Right. Oh, I mistakenly pressed the test. Let's switch back. So as you can see, we can just list all the states here. So let me list all of them and save you a little bit of time. Cool. I just finished all the mapping here as FSM. So as you can see here, all the states are listed here, and within each item we have another list. Sorry, we have another dict which contains the event and the final state. All right. So how can we use this one? As you can see from the examples here, we will receive a list of events and finally return a final state after all the events. You may still remember there's a function called reduce in Python, so we can do it like this. Func tools. So since the initial state is closed, we can say reduce change state, which is a function we haven't defined, and events, which contains a list of events, and the initial state is closed, right? So this is actually the final state we should return. And also, if there is a state change that is impossible, so we should return. So how can we do it? Simple. Let's first define this change state function here. As you may still remember, we needed two variables here. So let's say the first variable is current state, and the second one is event. What we should return? We can say FSM under current state. If there's an event, we should return the mapped state. Right. Yeah, that's just quite simple here. But how can we handle this error? Simple. If, let's say, as in this example we have gone through, time wait state, if we have absent event coming in, so we should put the current state here, so which is time wait, and then Python will check this item. If the absent coming in, there's no matched key here, then Python will raise a key error. So we can actually catch this error message to return error. I think this will be enough. Let's actually do it by testing it. Cool, we passed the tests, and let's try the random ones. Perfect, we passed all the tests. Okay, let's submit the solution and head to the next kata. I will see you next time.